This is pre-algebra lesson 2-3, simplifying variable expressions. There's quite a bit of vocabulary that's important within this lesson, so be sure you're paying attention. A term is a number or a product of a number and a variable. Terms are separated by addition or subtraction signs. For example, 3x is a term, 6 is a term, negative 5xyz are all single terms. If I wanted to write something like 2x plus 6, this is a phrase that has two terms. It's an algebraic expression that has two terms because this is one term, the 2x is one term, the 6 is a second term because it's separated by a plus or minus sign. A constant is a term with no variables. In other words, it's a number. So in the above example, 2x plus 6, 6 is a constant. Okay? Like terms are terms with the same variables raised to the same power. For example, 3xy to the third and negative 7xy to the third are like terms because they both have an x, y to the third. The constant terms, the coefficient, the 3 and the negative 7 doesn't matter. It's the variables that matter. You have to have the same variables raised to the same power. They don't necessarily have to be in the same order, but they have to be the same variables raised to the same power. A coefficient is the number that multiplies a variable. So in the above example, the coefficients are 3 and negative 7. And last but not least, deductive reasoning is the process of reasoning logically from given facts to a conclusion. Okay, deductive reasoning is important because it helps us to think logically. All right, so let's take a look at something for just a quick second. I'm going to write down an example here. Let's say we have 5x plus 7y minus 4x plus 3. In this particular algebraic expression, we have four terms. Okay? These are all called terms. Okay, those are terms. Because they're all separated by an addition or subtraction sign. Okay? The 5x and the negative 4x are what we would call like terms. Same variables raised to the same power. Okay? The 5, highlights, okay? The 5, the 7, and the negative 4, notice I'm assigned as a number. Those happen to be coefficients. And last but not least, the 3 is a constant. It's never going to change. 3 will always be 3. When 3 stops being 3, I stop teaching math. Simple as that. All right. When you have a variable expression that includes subtraction, it's sometimes helpful to rewrite the problem as an addition problem so that you can better identify the terms. For example, 5x plus 7y minus 4x plus 3. Sometimes it's a little bit easier to make that minus 4x a plus or negative 4x like we did right here, because then it's easier to identify your like terms and it's easier to identify coefficients and variables. Sign goes with number. If you have a positive sign in front of a number, that means that number is positive. If a negative sign in front of that number, it means that number is negative. Okay? All right, let's take a look at some problems. We're going to name the coefficients, like terms, and constants. Okay? Coefficients, like terms, and constants. In this, remember, coefficients are numbers that come in front of variables. So my coefficients in this problem are 2 and 4. Like terms are terms that have the same variable raised to the same power. So my like terms here would be 2x and 4x. And last but not least, my constants are numbers that don't have any variables, so that would be 6. Problem number 2, we're going to find out constants. Coefficients, like terms, and constants. Coefficient. Okay, in this case, it's negative 8. Remember, sign goes with number. It has to be negative 8. It's not positive 8. My like terms, we don't have any like terms. We only have one term. Okay, so there are no like terms, and constants, there are also no constants, because there's nothing other than one term and it has a variable next to it. Look at number 3, again, coefficients, like terms, constants. Coefficients, like terms, constants. My coefficients, numbers in front of variables, 2 and negative 2, because I have positive 2 in front of the x and negative 2 in front of the m. Okay, and I have a 9 in this fact, so we have 9, 2, and negative 2. My like terms, 9m and negative 2m, because remember I can change this to a plus the opposite. Sign goes with number. And my constants, we have none. And there are no constants. Okay. When you simplify a variable expression, you want to work the problem out as far as it can possibly go. Sometimes that means you will arrive at an answer. Sometimes you will just arrive at some more specific, or to a more simple form of the problem. So if we're going to combine some like terms. Okay, again, I could use algebra tiles, but algebra tiles are really annoying. Okay, I could use algebra tiles. In fact, let's just do a problem with algebra tiles. For this particular problem here, I'm going to let this equal a, this equals 1, and solid equals a. Okay, so I have 3 a's. So I have 3a, 1a, 2a, 3a plus 2, 2 plus 4a, 1, 2, 3, 4, plus a negative. So I was going to combine those. 1, 2, 3, 4, 5, 6, 7, 1, 2, 1 solid. So there we go. So if I combine those, I have 7a. If you notice, this becomes 0, so it'll go away. Plus. Okay. But using algebra tiles can be very cumbersome and very annoying. Okay, so just as easily I could have said, oh, 3a's and 4a's, 3 plus 4 is 7, that's my a1, and then positive 2 and then negative 1 becomes positive 1. Same thing. Over here, problem number 5, I have 3b minus b. Remember, when a variable is written without a number in front of it, there's always a number there. It's assumed to be 1. This is the same thing as saying 3b minus 1b, or 3b plus a negative 1b. So it becomes 2b, because those are like terms. Problem number 6 here. Negative 4m minus 9m. Same as saying negative 4m plus negative 9m. Okay? So basically, negative 4 plus negative 9 times n. That's equals negative 13m. Okay. Number 7 here says that's 1p plus 6p minus 4p. So 1 plus 6 minus 4 all times p. So 7 minus 4 is 3, so it would be p is my answer. Okay. Now we're going to simplify. We're going to justify. We're going to say what allows us to do what we did. Okay, that's what justifying each step is. So I have 6y plus 4m minus 7y plus m. So the first thing I'm going to do is I'm going to do 6 minus 7 times y plus 4 plus 1 times m. Because all I did was take my like terms here, and I just used the distributive property to separate them so that I could deal with the numbers separately from the variables. So 6 minus 7 is negative 1y, plus 4 plus 1 is 5m. Okay? And all I did here was combine my terms. My final answer is negative 1y plus 5m, or negative 1 plus 5m, same thing. This problem here, before I can even look for like terms, I have to distribute. And I'm going to put a plus a negative 2 here to make sure I distribute a negative through that 5 plus x. So So I have 4x plus 3 plus negative 2 times 5 plus negative 2 times x. So now, according to the order of operations, I actually have to multiply those first. So I have 4x plus 3 plus negative 10 plus negative 2x. Alright, so the first thing I did was the distributive property. Okay. Now I'm going to actually do the associative property for x minus 2x plus 3 plus negative 10. This is the associative property. Okay, so I just grouped them differently. Now I'm going to do like terms. 4x minus 2x is 2x. 3 plus negative 10 is equal to 7. So these are supposed to come up like terms. So there we have it. This is simplifying variable expressions. How do you simplify things that have variables? Now, like I said, you're not going to come up all the time with an answer like -6. Because if there's a variable involved, you can't unless you know what your variable is. So be aware of that.